Subarray sum equals K. Derive the prefix sum and frequency map solution instead of memorizing it. The input is nums equals 1, 2, 1, 1, 1, and K equals 3. A subarray is one continuous slice. After choosing a start and end, we must include every value between them. The valid slices are 1, 2 at indices 0-1, 2, 1 at indices 1-2, 1, 1, 1 at indices 2-4. Different start and end pairs count separately. Therefore, the required output is 3. We return the number of valid subarrays, not their values or indices. A direct solution chooses every start index, extends the end index, and keeps a running sum for that start. There are quadratic many start and end pairs, so the optimized brute force solution takes O of n squared time. A normal sliding window is not a general replacement. With negative values, expanding can lower the sum and shrinking can raise it, so the usual movement rule is unsafe. We need a method that recognizes a completed range without testing every possible start. Start with the input 1, 2, 1, 1, 1. Build the running totals. The prefix values are 1, 3, 4, 5, 6. Prefix at index I includes every value from index 0 through I. This definition matters. A prefix is not an arbitrary range and it never starts in the middle. Focus on the valid range from index 1 through 2. The current prefix at index 2 contains the answer range plus everything before it. The current prefix is 4. The earlier prefix is 1. It represents exactly the values before the highlighted range. Subtracting gives 4 minus 1, which is 3. The earlier values cancel, and the highlighted subarray remains. The sum of a range ending here equals the current prefix minus an earlier prefix. We want that range sum to equal K, which is 3. Rearrange the equation. The earlier prefix we must find equals current prefix minus K. That is why the algorithm calculates need as prefix minus K. It is derived from the range equation. It is not a memorized trick. The hash map contains prefix totals from earlier positions. Each row stores a prefix sum and the number of times it has appeared. The same prefix total can occur more than once. Each occurrence is a different earlier boundary, so each one creates a different subarray ending at the current index. That is why a lookup adds the stored count, rather than adding only one. Initialize prefix sum 0 with frequency 1. It represents the empty prefix before index 0, so a valid subarray may begin at index 0. Without this seed, a current prefix equal to K would not find the earlier 0 boundary. For every value, first look up need, then add its frequency to the answer, and only then store the current prefix. Lookup must happen first, so the current prefix cannot match itself, and create an empty subarray when K is 0. At index 0, the current value is 1. The running prefix before reading it is 0. Add 1, so the current prefix becomes 1. A target sum subarray ending here needs an earlier prefix of 1 minus 3, which is minus 2. Look only in the map of earlier prefixes. Prefix minus 2 has appeared 0 times. Because prefix minus 2 has not appeared, no start boundary can create a sum of 3 ending at index 0. The answer remains 0. Then store current prefix 1 for future indices. At index 1, the current value is 2. The running prefix before reading it is 1. Add 2, so the current prefix becomes 3. A target sum subarray ending here needs an earlier prefix of 3 minus 3, which is 0. Look only in the map of earlier prefixes. Prefix 0 has appeared 1 time. Those 1 occurrence create one valid subarray ending here, covering 0-1. Update the answer from 0 to 1. Then store current prefix 3 for future indices. At index 2, the current value is 1. The running prefix before reading it is 3. Add 1, so the current prefix becomes 4. A target sum subarray ending here needs an earlier prefix of 4 minus 3, which is 1. Look only in the map of earlier prefixes. Prefix 1 has appeared 1 time. Those 1 occurrence create one valid subarray ending here, covering 1-2. Update the answer from 1 to 2. Then store current prefix 4 for future indices. At index 3, the current value is 1. The running prefix before reading it is 4. Add 1, so the current prefix becomes 5. A target sum subarray ending here needs an earlier prefix of 5 minus 3, which is 2. Look only in the map of earlier prefixes. Prefix 2 has appeared 0 times. Because prefix 2 has not appeared, no start boundary can create a sum of 3 ending at index 3. The answer remains 2. Then store current prefix 5 for future indices. At index 4, the current value is 1. The running prefix before reading it is 5. Add 1, so the current prefix becomes 6. A target sum subarray ending here needs an earlier prefix of 6 minus 3, which is 3. Look only in the map of earlier prefixes. Prefix 3 has appeared 1 time. Those 1 occurrence create one valid subarray ending here, covering 2-4. Update the answer from 2 to 3. Then store current prefix 6 for future indices. Here is the complete interview explanation. Maintain the sum from index 0 through the current index. For a range ending here to sum to k, an earlier prefix must equal current prefix minus k. Add the frequency of that earlier prefix, then store the current prefix for future positions. Initialize count of 0 to 1, perform lookup before insertion, and return the accumulated count. Every value is processed once. Time is O of n, and extra space is O of n. Store prefix 0 with frequency 1 so a range beginning at index 0 can be counted. Process each value once and add it to the sum from the beginning of the array. Look up prefix minus k. Its frequency equals the number of valid starting boundaries for ranges ending at this position. Only after counting matches, increase the frequency of the current prefix so later positions can use it. Return the accumulated number of valid subarrays. The scan is O of n, and the map can hold O of n prefix sums.